Hi class, Miss Womack with Completing the Square, this time with parabolas. So when do we know we need to complete the square? When we are looking at an equation that kind of looks like this one, and we need to have it in a standard form like this one. The one over here is our standard, and that's what we'll be calling general form over to the right. So what do? Well, these guys need to vacate the premises. And how are they going to do that? Well, using inverse operations. I'm going to take a little shortcut. Again, I'm justifying this by, if I add 8y, then it will be moved over here, and I have to balance the equation. So there it is. And I'll do the same thing. I see a plus 17, so I'm going to subtract 17. Now let's get back to the order of business, completing the square. Dropping the x squared minus 6x and leaving a space. And remember the step? Take half of this term here and then square it. Half of it's 3, squared is 9. I'm going to add 9 to this side. So now we've added a new element, 9. We cannot, it's no longer balanced in the equation. So we must simply add 9 to the other side over here. So let's get to work. Plus 9. Now, we'll go ahead and simplify this on the right side of the equation, combining like terms. Again, negative 17 plus 9 is going to be minus 8. And then I'm going to bring down my 8y. I'm now going to pull out a greatest common factor of 8 and have y minus 1. And that side of my equation is all done. Now let's work on the other side of the equation. Again, we're looking for a term that when multiplied by itself gives us the 9 and added together gives us the negative 6. And what better term than negative 3? Again, if you need to practice the multiplying with FOIL just so that you'll readily recognize these, go right ahead and do it. So we can see now that this equation, based off of looking at this portion right here, I don't see a negative sign. So I know that is going to open where? Up. Now, I can solve for p because I know that p is, this portion of the equation also right here, is equal to 4p. So if I set that 8 equal to 4p equals 8 and I solve it, then I'm going to see that, again, dividing by 4 on both sides, p is going to be equal to 2. Now this is very significant. We know it opens up. We know that the p, which is the distance between the vertex to the directrix and from the vertex to the focus, is equal to 2. So let's move along. This time we need to go back to our standard form of the equation, change those two little signs, and come up with our vertex, which is going to be 3, 1. Now, let's start putting some of the pieces together over here. Go over 3 up 1, put a dot, and what is the name of that dot? That is the vertex. Now, we know it opens up, and we know that p is equal to 2. So from the vertex, I'm counting down 1, 2. And I know since this points up, that right there going through y equals negative 1 is going to be our directrix. Directrix. Well, it's not going to fit. I'll put it down here. Directrix. Okay. So we can now find our focus, and we're going to jump 1, 2 up. And this is going to be our focus, which is located at 3, 3. So let's fill in some of the blanks over here. 3, 3 is our focus. Y equals negative 1 is our directrix. And last but not least, let's identify the axis of symmetry. Now we haven't drawn it just yet, so we're going to fill it in. We know it's going to be kind of this shape here. And I realize that it may not be completely accurate at this point, but what I do know is it turns up and it splits in half right through the focus and through the vertex, right through here. That, my friend, is called your axis of symmetry. It's passing through where x equals 3. So in fact, we'll call the axis of symmetry where x equals 3. So there's an example of completing the square with parabolas.